Okay, so let us now take a look at the reverse algorithm. So here, we have to specify the address of the head. And then we have here, so in our example, the address of head is 120. So this is our list, 120. So head is pointing here, and this node is pointing here, and this node is pointing to this node, and this node is pointing to null. So that is our list. Now we want to reverse this list. So again, our argument is the address of the head, which is actually 120. And then we have here three variables. Previous is equal to null, or prev is equal to null. Current is equal to the address of the head for the argument. So current should be equal to 120, and next maybe still equal to null, or nothing is assigned to next yet. So the basic principle here is to just change the value of the next pointing to the previous. So let's take a look at the code. So while current is not equal to null, so our current is not equal to null because it is 120 in this example. So next here now is equal to current next. So this is our current. So current next is actually 110. So next here becomes the address, which is actually 110. Current next is equal to previous. So this is our current. Current next should now be pointing to the previous value, which is actually initially null. So this should be pointing now to null. And then previous is equal to current. So we change now our previous to the current. So previous now becomes 120, which is the value of current. And current now is equal to next. So current becomes 110. So we move to the next two nodes. And then we go back to our loop condition. Current is not yet equal to null. So we again proceed inside the loop. Next is equal to current next. So this is our new current. Current next is 100. So that will be the value of next. So this becomes 100. Becomes 100. Then current next. So again, this is current. Current next. So this one is current next is equal to previous. So previous is 120. So this one now is 120. As you can see, this one is now pointing to the this node. Okay. So current next is equal to previous, and previous is equal to current. So current is 110. So this becomes 110. 110. And then current is equal to next. So current is equal to next. So this becomes 100. So we change the values of the two adjacent addresses. Then if you go back to the loop condition, current is not yet equal to null. So that's correct. So we go again inside the loop. Next is equal to, so this is our current. Next is equal to current next. So current next now is equal to null. This is current. So next becomes equal to null. And then current next is equal to previous. So this is current next is equal to previous. So this becomes 110. And then previous is equal to current. So this becomes 100. And current is equal to next. So current is equal to next. So this becomes null. And then our head now. So this is actually the head because it will be used for our argument is equal to previous. So 100 now becomes the value of head, or that's the address where head is pointing. So if you're going to look at the list, we will start with head. Head is pointing now not to this node but to this node. So that was previously our last node. And then this node is now pointing to this node. And this node now is pointing to this node. So 120 pointing to 120. 110 pointing to 110. And this one is pointing to null. That means it's the end of our list. So as we can see that our list is now reversed. Now let's take a look at our sort algorithm. So previously we already have our sort algorithm, the bubble sort algorithm. So here we're going to use again bubble sort. So again in bubble sort we have our variables. So I think we're not going to use others here. So we have the temporary key and temporary data that will be used for swapping. So we have our swap indicator. Again 1 if they're swapping, 0 if none. And then we're going to track two nodes. These are the adjacent nodes, the current and the next node. And then the size is equal to the length of the list. And then k is equal to size, but we're not going to use this variable, I believe. So swap is equal to 1. And while swap is equal to 1, so we keep on comparing two adjacent elements. Okay? So just like what we have discussed previously in our bubble sort algorithm video. So while swap is equal to 1, then first we set swap to 0, and then we now keep track of the two adjacent nodes. So current is pointing at the head, and next will be where head is head dot next. So that's the next element. So head and next. So initially that's null and first one. So again, but basically this is comparing two adjacent elements. So we loop until we reach the second to the last element, just like what we have done last time. And then next we compare the two adjacent data, so the current and the next one. So if the current is greater than the next, what we're going to do, we just exchange the values of the data, not the nodes themselves, but just the data of the node. So we assign the current data to temp data, and then the next data to current data, and then temp data to next data. So we have swapped the values of current and next. So do the same thing with the key. So the current key to temp key, next key to current key, and temp key to next key. So since if the control of the program will pass through this, then that means swapping was done. So if swapping was done, then we place swap is equal to 1. Then you proceed to the next element. So you move to the next element. That's why the current one is equal to the current next, and next is equal to next. Okay, so that means we're moving to the next two adjacent nodes. So we do this until the time that there will be no more swapping. Okay, so to check, let's take a look at our code here. We have inserted several elements, so 6 elements, 6 nodes. And then first we print the original list, and then in our code we deleted the first element until the time that our node is empty. So this will also test if our isEmpty function is working. So, and also our delete first. So this will also print what are the keys, or what are the nodes that are deleted, the key and the data of the nodes that are deleted. Then after that, we try to print the deleted list. Of course, we're expecting that to be blank. And then, so we try to reinsert the nodes. So we restore the list and then print the list again. Then after that, we try to test the search algorithm. So we try to find 4, and that actually could be found inside our inside our list. So that will display found. Then once we found 4, we delete 4. So that is to test the delete algorithm. And then we try to list after deleting. And then we again find 4. Of course, this time around, the search should not be successful. So we're expecting element not found after deleting 4. Then next, we sort. After we sort, we print the list. Then we reverse. So this was discussed a while ago. Then once we reverse, we just give the address of the head. So we place the address of the head. And then we print again the list, expecting the list to be reversed after printing it, after sorting it. So let's try to look at the output. Okay. So first, we printed the original list. So you notice our key is reversed because we use insert first. So the last we inserted will be placed on the first as our will become our first element. And here we deleted all of the elements until it's empty. And while deleting, we display what we deleted. So we deleted the first element until the last element, so that the next code will display again the list. So this time around the list is empty. Then we restore the list, so we reinserted everything. So once we print the list, it will print again the list. Then we try to make use of the find function. So we use to find 4. We find 4 and then again it's found. Then we deleted 4. So once you deleted 4 and you print the list, 4 is no longer here. And we search again, we use the find function to look for 4, and then it says here element not found. The next time we sort the data, we sort the list or the element or the list according to the data. So then we printed the list. So you notice our data here is now sorted from lowest to highest. So the first element is 10, and then 20, 30, and then 40, and then 56. So it's now sorted from lowest to highest. Then in the next code, we made use of the reverse algorithm. So once if we reverse this, so this will be the output. So the last output or the last element in our node previously is now our first element. And then so the next one, 3, and then this, and then this. So this now reverse. So more or less our code is working. So thank you very much.